Alrighty. I did the movie Fermat. It is a Spanish movie, so if you look it up and you get a really badly translated version, that's the version I watched. I don't think it was English. It wasn't even Spanglish, because I would have understood most of that. It was a really bad version, but it's basically all of these people get locked in a room and they have to figure out puzzles to get out, and they all have aliases of famous mathematicians. So the first one is Fermat. He's the guy who initially locks them all in the room. So I'm going to focus on Fermat's last theorem. This involves what we know as like the Pythagorean theorem. So the original thing was Fermat claimed to have discovered a proof that the equation x to the n plus y to the n equals z to the n has no integer solutions for any n greater than 2 and x, y, and z cannot equal 0. So that includes our Pythagorean triples and stuff like that. No one could find this proof. He wrote down just like this part on a margin of a book, and no one could find the proof for years. This is the guy who eventually ended up figuring it out. His name is Andrew Wiles. He did a very long, lengthy proof, but in the end, he kind of just proved this in a big way, because he used a lot of abstract algebra that I really did not understand, even though I spent like 3 days trying to learn abstract algebra. But here are some of our known Pythagorean triples that we use. But his proof, he spent I think it was 24 hours just figuring out where to start. And he did a conjunction proof. So he basically started off his proof by saying that this is wrong, and then went on through his proof trying to prove it wrong. And in the end, he actually proved a few other things were correct at the end of it, just because there had been other people that tried to use their own theories to prove this, and they've only been able to prove one number at a time. And this is where me and Mr. Kruger got into Bernoulli numbers. Well, while we were trying to figure out some abstract algebra, I walked in one day, Kruger, he goes, "I think I figured it out." He's got a paragraph, he's got 4 pages of notes. I was like, Kruger, you got way too far into this, because we looked up what an irregular prime was, because one guy had figured out that it had to be regular primes. But an irregular prime is just any prime that's not regular. So we had to figure out what a regular prime was, and a regular prime was any prime that was divisible or multiple.
Yeah, it has a divisibility with a Bernoulli number.
Yeah, and a Bernoulli number, just looking at it made me kind of want to cry. I looked at it, and then he brought in, the next day, he brought in it was 24-page, print off of Bernoulli numbers, and I was like, you're diving way too far into this. So that's how that went. But yeah, this guy discovered that it actually is true. His proof was really long. He included a lot of abstract algebra. And then this is what we usually use in calculus. Otherwise, everything else is usually used in abstract algebra. Next on, I included math riddles. Who wants to take a guess? I added 6 to 11 and get 5. Why is this correct? Yes.
Is it negative 11?
No.
Is it a base 10, or is it 6, 11, and 5
Nope.
base? So it's a different base. Oh, it's in base 10. Oh, okay.
Is the 6 negative?
No. No negatives.
Does that have to do with all the numerals?
No. Answers at the end. This guy, that's not how his name is pronounced. It's pronounced Galois. Interesting. He was French. He created a relationship to describe how roots of polynomials relate to each other, mostly using groups in fields. Here's where we really get abstract algebra. I spent 3 hours one day watching abstract algebra videos and got nowhere. But I did learn about the difference between a group and a field. A group includes multiplication and addition. That's the only two operations it deals with. Your multiplication has to be associative, and there has to be an identity in it, and each element has to have an inverse. Fields include addition, multiplication, subtraction, and division. And that's kind of how it makes it different than groups. Groups are much smaller. They include a smaller variety of numbers at the end. A ring includes multiplication, addition, and subtraction, but does not include division. So that's why fields are again a little bit bigger. And in the field, a rational number are not uniquely defined. So this is what it originally said. So this would be how he described the relation. No, this is how the relationship is originally defined. So these are fields, and then he scooched it over so that they all have, this basically made it into a group. So he figured out a way to make the really expansive field into a group, and a few other varieties of that. Otherwise, this is a very blurry picture, but it says a polynomial of x squared plus 1 has a root I, and that is included in a field because it has to do not with multiplication or addition. And then this is like, you can shuffle the objects around, everything is associative. And this just shows how the roots move. Alright guys, another one. Old Granny Adams left half of her money to her granddaughter and half of that amount to her grandson. She left a 6 to her brother and the remaining 1,000 to the doghouse. How much did she leave altogether? Yes, Alex.
12,000?
Yes!
Chloe, can I ask you? I didn't hear the answer for the first one.
No one figured it out, so you get to know at the end. It's clear.
Oh, at the end.
It's a cliffhanger.
Oh, okay, I got it.
12,000 is correct. Alright, Hilbert. Hilbert is an addition of the last guy we talked about. In his theory, he actually uses the last guy. But his main idea was that all mathematical problems could be ultimately solved and that the foundations of mathematics should be based in logic. He created the theorem of invariance, that all invariants could be expressed in terms of a finite number. So, this was his original, long theorem. Well, actually, this is the shortened version of it. I read it one day, and it was like 3 pages long, and I didn't understand anything from it. But he also worked a lot in astronomy and stuff with just like space, which is really interesting because I found that first before his big theorem. But this is his invariant line element. So he figured out this, got to here. This is from the last guy, and then it opens up all of these. And this is a group. And this is the inverse down the center. He created 23 unsolvable problems. So far, number 3, 7, 11, 13, 14, 17, 19, 20, and 21 have been solved. I looked up one. It's not even just a problem. It's like a paper. It's not a problem. It's a paper. They want you to solve a paper. And then all of them have like subcategories in them. That's for the reason that they're like papers. So
Are these the problems that you get money for?
One of them is.
yeah.
I noticed one.
You know, the Riemann hypothesis.
Riemann hypothesis on the top right there.
So number 3 has been solved. Number 7 has been solved. Number 11 has been solved. 13, 14, 17, I believe, 19, 20, and 21. This one, number 23, is like the one that everyone's trying to figure out. No one has figured it out yet. It's like the most popular out of all of this. You guys ready? Another one. What single digit appears most frequently between and including the numbers 1 and 1,000?
Oh, it's got to be 3.
Oh, nope. It does show up 300 times though, in case you're wondering. I chose to do math riddles between all of these because in the movie they had riddles, and that's basically, it's kind of like the Saw movie, except less morbid. But they did, like, the rooms were closing in on them and all that stuff, and in the end they figured out how they were all connected and stuff like that. But they had riddles, and I didn't want to use the riddles that they had and ruin the movie, so I found my own riddles. Does anyone have an answer?
If we say all the digits.
Well, eventually.
You'll have to get to one.
0.
No.
That's not the
That was my second guess.
One.
Yes,
Okay.
Nailed it.
because it starts at 1 and then it'll go all the way up and they're all included, but it starts at 1 again. And this is your extra one, so 1 appears 301 times. Every other number appears 300 except 0. Pascal, I have 3 different laws for him. We have what we usually talk about, which is the triangle, which is an arrangement that gives us coefficients and expansion of any binomial expression, such as this one. Then the wager is the posit that human beings wager with their lives that God either exists or does not. And then he has a physics rule, which in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. So, here's a triangle, as we know. Goes up and down, and then you have our 3 rows based on what the n is right here. That's how we know which row we're doing. Because if you put that to the 0 power, everything to the power of 0 is going to be 1. And then if you put it to the 3rd power, you have like x cubed plus 3x, I think it's 3x squared y plus 3x y squared plus y. That's probably this one actually. That one's cubed. And then here's the wager. I thought about whether or not to put this in here, but it does include a probability, which is very interesting to me that he thought all of this time about God and the probability of it existing. He had all these other cool things, and he spent a lot of time thinking about whether God exists or not, and whether it was worth it if he did or didn't, because he actually didn't know. But he said, if there's a God and you believe there was infinite reward, if there's a God and you didn't believe it was infinite punishment, and if there's no God and you believe it's infinite loss. You didn't gain anything by believing and you lost time. And then if there's no God and no belief, you have finite gain. Because you didn't spend any time and at the end there was nothing, but you didn't gain anything at the end. And then here is his physics law. So it says that this pressure has to be the same as this pressure, and you can find that based on the force here in the area of not how big your tube is, but how big your little pressor is. Other one. If a hen and a half lay an egg and a half in a day and a half, how many eggs will half a dozen hens lay in half a dozen days? Oh, and you got it? You're just shaking your head.
I just didn't even think about it.
Shoot out a number.
What's your number?
6.
No,
Wow, I knew that. Sorry.
16.
no. All right. The last person was not someone who did mathematics in a sense of logic. She really just thought of it as a spiritual thing. So she believed that the soul is divided into 3 parts: the sensitive, the biological, and the intellectual soul, all of which would be in harmonic balance with one another. The balance between the 4 humors, hot, cold, wet, and dry, must also be in harmony in order for a human's organ system to be in a healthy state. She used temperature, humidity schematograph from Hippocrates to evaluate illness and individual state health. She worked a lot on people's spiritual health as well as their physical health. She was a doctor that was taught by her father, and her work was published really late. Someone else published it for her because she is often overshadowed by Hippocrates and other known known doctors of the time, and it was really a shame because she knew a lot. And now that her work is being brought up, she's getting many books written about her and all of her theories, because this is just one of about 4 that are known at the moment. Alright guys, this is the last one, it's really long. 3 friends are on a road trip and they rent a triple room for a night. When they get to the hotel, they pay the fee of $30 and go up to their room. The porter brings up their bags and refunds them $5 because the hotel is running a weeknight special. The 3 friends each keep one of the dollars and give the porter a $2 tip. Later, they sit down to work out their expenses for the weekend and find they have a problem. They each paid $10 for the room and got $1 back each, making their contributions $9. Then they gave the porter a $2 tip. However, 9 times 3 is 27 and plus 2 is 29. Where did the extra dollar go?
It's taxes.
No.
Good guess. If you look at it in a way where they spent $25 total,
Yes.
and then they kept $3, so they're at 28, and then another 2 went to the
Yes.
person. Where did it go and all
Where
that?
did it go at the end?
You ready for the answers?
My favorite's got it.
No, he does not.
Okay.
Alrighty, so the first one is think of it as a time, 11 plus 6 hours
Oh,
plus
that's
5 p.m.
Oh,
Alex
okay.
got the second one. I think Alex got the third one. It's 2 dozen eggs. And they did bad math. They paid $25 for the room and $2 for the tip. The extra $3 was already given back. The
Well,
end.
We had it.
We have it.